The broadcast is now starting. All attendees are in listen-only mode.
Good evening, everybody, and welcome to the year-end episode of vBrownBag. We've got a very special episode tonight. We're going to be talking with Cody, Grant, and John, sometimes known as Jay, about VMware Cloud Automation Services. That was a joke. And so a couple of housekeeping notes before we get into it. Please get in on the conversation at vBrownBag if you're on Twitter. We will be responding to questions and Q&A from there. If you are in the live studio audience with us tonight, we will be also responding as well. John has graciously taken up the reins of the Q&A moderator for the Peanut Gallery, so he'll be doing that for me. And we've got a little bit of a special guest over here. So let me flip over to a different PowerPoint to tell you about the vBrownBag annual, oops, no, not that one, the vBrownBag annual giveaways. If you go to the vBrownBag website, we have a number of gifts to give away. HYCU, Presidio, Nutanix, VMware Education, they've all given us some really cool gadgets and gizmos to hand out, as well as Nutanix Turbonomic. We've got 2 copies of the IT Architect Journey from VMIS. We've got 1 copy of Designing Risk and IT Infrastructure, and we've got a VMworld backpack with Explore VM swag from explorevm.com. So if you go to the vBrownBag website and register for the year-end giveaway, you could potentially win some very cool swag. So with that being said, let me turn the reins over to the boys so that they can talk to you about CAS. Cody, Grant, John, who is going to be running the show?
I will start off. So
all right.
Cody will start off. I was going to do like a fake Australian accent and try to say, hey, this is Grant. But what are the odds?
I want to hear that. I want to hear that.
What are the,
bring your Aussie accent, man.
I have not had enough booze yet. That's a horrible idea.
Are you gonna land on South African or British, man? I want to hear this.
Greg might be in the audience. He will grade your South African accents. All right, Cody, I can see your screen.
Awesome. Give me 1 second. We will kick off. I was wondering, from a giveaway standpoint, could we get Grant to give away like a bloomin' onion? Is that a thing?
I think we discussed this. They don't really make those there. He calls that American food.
Yeah,
American Aussie food. Do you actually grill shrimps and call them Barbies, though? That's what I need to know.
Well, we grill prawns. We don't grill shrimps.
Because too small.
We do it on the barbecue. So yeah, that is totally a thing. In fact, I might do that this afternoon.
Oh, I'm so jealous.
Fantastic. All right. So jumping in again. So our idea was to come on and take people through showing the hands-on lab for Cloud Automation Services. So this is the 3 best friends anyone could have: Cloud Automation Services and Chris, because you're not included in either of those things. Just to add that last part on in case it wasn't clear by the fact that I separated you out here.
I'm just the host.
So a little bit of intro as we get started for those who don't know any of us, which God, I don't know how that would happen. So I'm Cody D. Arkland. I'm a member of the Cloud Management Business Unit. I'm in tech marketing, which means pretty much all I know how to do is use PowerPoint and a web browser. So it's pretty simple stuff. You can find me on Twitter often at Cody D. Arkland. Grant, take it away.
Yeah, Grant Orchard. I'm a systems engineer based out of Sydney, Australia. Been playing around with VMware's automation stack for a little while now. Over to you, John, Jay, whatever your name is.
Yeah, so I'm actually John. I don't know where the J came from. That's just the amusing typo of the evening. And I'm actually a product line manager with VMware's Cloud Automation Services. So I'm part of the outstanding PM team that researches and lays out the future for this thing. And we're really pleased to be able to show it to all of you. I'm also apparently the only one with a blog that doesn't have an SSL cert. I didn't realize I was going to be judged quite so harshly for that, but there it is.
Oh. All right, and before we get into to the real stuff, just wanted to call out
Amazing.
So we're really happy to have Grant joining us straight from the Outback. It's really a magical thing for us all. All right.
As we've set the tone for the evening. Hold on, I got to go get a drink.
On the serious mode. Oh, so the real reason you guys are all here is not to hear us talk about Grant and his crocodiles. We're here to talk about cloud automation services. So cloud automation services is the evolution of what VMware is doing from a automation of infrastructure, automation of platform deployment, situation, if you want to call it that. We started off with vRise Automation, which many people are familiar with. It's been on vBrownBag many times, and vRise Automation is growing into this thing called Cloud Automation Services, which is really just 3 different products. It's Cloud Assembly, which is a good way to think of that as the administrator view of the platform. It's where you're creating blueprints, you're building projects that you're assigning users to, you're connecting cloud accounts, you're setting up cloud zones that let you move workloads between multiple clouds. So AWS, Azure, vSphere, maybe some other NDA ones that John will tell everyone about. Moving on. Moving from a user perspective, Service Broker is the catalog experience. So it's where policies live. It's where users come in, they hit items, they hit request, they land on a custom form. It's where you can provision out CFTs, so Amazon CFTs or Cloud Assembly blueprints. A lot more content's coming to that in the future. Right now, the product's in initial availability. As we roll up on general availability and in early Q1, a lot more will be popping up within these products. And then finally, CodeStream. CodeStream is a bit of a unique creature who lives a little bit off to the side. CodeStream is really about release pipelining. It's about getting developers back to what matters to them the most, and that's committing code into GitHub repos. But it also, or not necessarily just GitHub, just Git repos in general. But it also has a really good infrastructure administrator story around how it automates the ability to deploy infrastructure into Cloud Assembly. Given the time constraints we have around the presentation, I don't see us getting really much further than probably Service Broker. We have a couple of experiments we're going to run through, primarily in the hands-on labs. I'm primarily talking through the hands-on labs. But we can certainly answer questions about anything on the board, and that's why John's here from PM. So again, just really diving into what each one of these are all about. In Cloud Assembly, we're going to be building blueprints. That's something we're going to take everyone through today. We're going to show how you can do this right now in the hands-on lab. And the hope is for the couple people who are joining as we're going through this, that you'll go on to labs.whole.vmware.com, John, I think, and look for whole 1921, 1921-03. Or I'm sorry, 1921. Geez, that's my lab. 1902. 1902-03.
That's right.
And walk through this with us, because you get a real Cloud Assembly, Service Broker, CodeStream environment there. You get a pod with vSphere. You get connectivity into AWS and Azure. So like, I know, Chris, you're super up on AWS stuff these days. You can go in there, and when you log in, you'll actually have an AWS account bound to Cloud Assembly, so you can immediately go out and start provisioning workloads into AWS.
Is this hands-on lab up and running now?
It is up and running right now, so you could go log in, and our hope was that some of the people who are dialing into this will go in, log on, and follow along with us as we're going through some of these exercises.
I'm doing it right now, actually.
Awesome.
Again, Service Broker, and this is kind of the view of where the product's going. This is not actually a confidential slide, despite the fact that the bottom tag says it is from our customer-facing deck. But this is a view of where the platform's going: the ability to deploy a Cloud Assembly, blueprints, CFTs, VRO workflows, so on and so forth, and then integrations within CodeStream, and the ability to build these multi-stage pipelines. The most common use cases are between dev, prod, QA, but it could be a number of different types of stages also. And there's a quick sample of some of the things that we integrate on the top right. With that being said, I totally typoed on the URL there, so it's labs.whole.vmware.com, not labs.vmware.com. But then look for the 1902-03 CMP lab for getting started with VMware Cloud Automation Services. So I'm going to go jump into that right now. I'm going to switch my sharing to be my browser instead. Should just be sharing that now, just the hands-on lab, right? Awesome.
You are indeed.
That's right.
Yep.
Magical. It's like crazy technology and stuff.
Super cool.
So I'm logged in right now. I get a couple of extra things because of being on the inside of the wall. But if you come up to all labs, you can actually just do a 1902-03 search, and it'll come up. I've completed this lab, which is a total lie. I've never been through the entire lab before, but that's okay. We'll go enroll again, and we'll start this lab. So many of you who've been through the hands-on lab, you've probably seen on the right the guide for getting through. There's a ton of work that actually goes into this, and that's something that I know John and I have talked about wanting to do a session on sometime. Is the work that actually goes into building this experience out is pretty crazy. We're not going to necessarily stick to the guide over here today. We're going to go a little bit off the tracks. But as you go through this, Grant specifically, and a guy named Chris Slater, also out of New Zealand or wherever they're from, they both put a ton of hours into building all of this content out, all 250 plus pages of it. So there's a lot of good content in here for how to get started. And it was actually completely refactored after Vegas and done pretty much live at Barcelona as we were going through the lab. So there's good stuff in there. Definitely go through that. On the other hand, I am just going to close that out. We're going to jump in. Now, you should be following kind of the same process as you go through the hands-on lab. So we're going to spin up this Google Chrome browser here. If our pod would unlock, there we go. The first thing you want to do is go up to this lab check-in box up here. Hit lab check-in. You're going to plug in your My VMware email address. So you have to have an account that's set up for My VMware. They're free. Just go sign up for one. Don't be that person who complains about it. It's not that big a deal. Super sensitive. Super sensitive. vBrownBag's where you go to have fun. It's not where you go to be serious.
This is true.
Oh, it's our festive event tonight, right? We decided that already.
I already have my aluminum pole up for the airing of grievances.
Well, happy Festivus.
Why am I not drunk right now?
You're not?
Only on emotion. Only on emotion for you, Jay. Only on emotion for you, Jay. So what's good? Search on there. You'll go ahead and click this link. And I want to take a quick second. Grant, why don't you talk about what happens when the person actually clicks this link? When they search their account and they fire this up.
Well, they get invited to the org. Do you want anything more than that?
Yes,
No,
I do.
I guess so what you're after here. So I guess just to give a little bit of background, typically in the hands-on labs, right, for those of you who've used them, you're effectively working within a vCloud Director pod. So we have this whole shrink-wrapped environment that we spin up. And when you finish with it, we just tear it down and the whole thing goes away. And the next time you come in or another person comes in, they get a brand new environment. Now, the Cloud Automation Services are SaaS, so we can't shrink wrap them inside a hands-on lab pod. So what we're doing instead is we're making use of the API to instantiate, as Cody was saying earlier, things like Amazon accounts and Azure accounts, creating a bunch of the backend config that you need in order to get started so that we can get to, as Cody will show in a moment, kind of the cool stuff, which is really how you go about doing the blueprinting and spinning out those different application infrastructure environments.
And the reason I wanted Grant to explain that, and this is something that John talks about a lot also, a big thing that's different about this platform versus previous automation that we've been a part of is that everything in here is backed by a REST API. So the fact that Grant was able to write a script that actually did all of this to add people to the orgs, set up those initial services, all of that is done via REST calls. Everything that you see today that we're going to move through in the UI, click through, and do is available as a REST API. We put out a blog on blogs.vmware.com/management of all of the REST API endpoints. Grant and I have done a ton of work around wrapping these in a Python kit that we use to call all of this stuff out, but it'd be very easy to wrap that in JavaScript or wrap that in Go and accomplish similar tasks. And hopefully before too long here, you guys will be able to see that a little bit more live. So, but important thing to note, it's just all available via API that you can do. So we're going to jump right into Cloud Assembly without wasting too much time. You've already seen kind of the overview of what the product is. Go ahead, Grant.
I was going to say, Cody, so now that you've registered, you could go ahead and log in from your own browser, right? Not actually through the hands-on lab session.
That's a great point. Now, that works great for the users who are out in the audience, obviously. It's going to be a little bit different for me because I have access to about 70 different orgs right now. But to Grant's point, if I launch the second browser tab and I come in, that's my normal one that I use from a tech marketing standpoint. But if I scroll through this list, you'll see that if I go back in here, I look down, it's HOL 1902 T5. I can actually go into that account here. Now, you guys won't have all of those different orgs available. You'll only have that one likely. But I can run all of this from my normal browser. So you saw when I was clicking around in here, it's a little bit laggy from a platform standpoint because we're obviously inside the hands-on lab, and sometimes there's a little bit of a delay between the two. I can bypass all of that, keep the pod running in the background, keep hands-on lab up, and I can access this directly from the browser. So now I'm getting that native experience of the browser. And since I'm going to be provisioning largely against public cloud, I don't actually need to be connecting into that backend at all. I'm just going to click around inside the browser anyway. So I'd encourage everyone to connect to it this way, access it this way. So we're going to dive straight into blueprints. We already talked a little bit about what the platform does, so I don't need to start down that path. But we can actually go in and we can start on crafting our first blueprint. We're going to go in, we're going to name this vBrownBag, and we'll select from a project. And we have a project already instantiated, and that project is where users have access to back-end compute resources. Shrink this down a little bit on the side so we get a little more space. So you can see our canvas. This should look somewhat familiar, but there's a couple of big things that are different from our previous canvas, and that's that we have this infrastructure as code object on the right, and we have the items that we can pull in onto the canvas on the left. We're going to dive right into a cloud agnostic object, and what makes the cloud agnostic object special, and John, I hope you'll jump in here on this. Cloud agnostic objects understand at an API level how to talk between each one of the cloud providers that we have. So in this case, we have an AWS account bound, we have an Azure account bound. If I tag this or I send this workload to AWS, it understands that if a load balancer is attached to deploy an ELB, it understands how to speak to AWS. But if I switch that tag and position it towards Azure instead, it understands how to pivot and go to Azure instead. Anything you want to add on that, John?
Yeah, so this is one of the most exciting things about cloud automation services, or cloud assembly specifically, are these concepts that we've got with these cloud agnostic objects, right? So one of the coolest things that we can do is give you the ability to model an application blueprint that can be written one time and deployed to any of the clouds that you've got configured. So really one of the goals that we have, the fundamental foundational goals of cloud automation, is that we want to make all of your different clouds consumed very seamlessly. So we want you to be able to use vSphere, AWS, Azure, eventually GCP, potentially others at some point, all from a single blueprint that you can write one time, and that's completely valid for any of them. So we've got, all of the mechanisms in place to let you do that, and Cody's going to show you, what that looks like here. So it's super exciting. It's one of the most fun things we've got in here.
And you'll notice that as I was dragging these objects out while John was talking, this blueprint was updating on the right over here. And this is easy for you to take and store and get and be able to pull back out later. It's easy to build versioning around via the versioning button here or storing it in your own source control. I know many of us will keep these locally and work on them in like Visual Studio Code. I have a repo on GitHub that has a bunch of my blueprints on that I share often with customers. So it's very powerful to have this code automatically updating on the right as you make changes. And you'll see as I start to link these objects up, that code continues to update. It's building bindings between. If I go into this routes and I want to build just like a simple HTTP load balancer, I can come in here, I can throw a port on of 80, I can do HTTP. Again, I can do 80 for the destination port, do HTTP for the destination, and that is a load balancer, right? I can just call it BBB LB. Now, Grant's script has gone through and it's crafted some baseline items for us. So I have Ubuntu as an image in here, and if I switch this flavor out, flavor being the sizes that are available, I'll do a small. The name of this doesn't actually matter, so we'll just call it default. Hey, Grant, what are the tags in the hands-on lab for moving between the clouds?
So you should be able to do platform. AWS or Azure.
Or I would have to do tag first, though. There
you
we
would
go.
have to do tag.
So
hey,
this
Cody,
is
did that auto-complete for you?
the tag part did, but the actual verbal tag does not. The actual tag on the end does not autocomplete.
We have loads of different autocomplete capabilities in here to help make authoring this YAML very easy for you. And I will say that we hope to be able to autocomplete those tags in the not too distant future.
So a lot of people are going to see this and they're going to wonder, like, what is this doing? We've gone through and a key concept that you'll want to learn about and pay attention to when you're working with Cloud Assembly is the concept of tagging resources. So in this case, when Grant built this out, he tagged the cloud zones, which are what hold the compute objects, with platform AWS. So when I tag this platform AWS, the provisioning engine within Cloud Assembly goes out and looks and finds objects within Cloud Assembly that are tagged that way. And when this goes to deploy, I'll back out and I'll show you guys the actual tagging and where it's at. But understand that this gives you a ton of flexibility. This is a very simple example doing platform AWS. But Grant, why don't you talk a little bit about the example you told me about where you guys were using it via compliance, like when you would move something between compliance levels?
Oh, sure. So I mean, we've been through this whole idea, for a very long time, which is, how do you identify resources by more abstract ideas? A lot of customers have, sort of these multiple factors that they take into consideration, things like performance or recoverability or security. So what we basically did was take an example from one of our customers, and sure enough, they call it basically the Ark Model, which is availability, recoverability, and cybersecurity. And so we built that out as kind of form factors so that you could actually sort of say, right, depending on the value that you put in, if you say, hey man, if you say cybersecurity equals 5 as the requirement for where this needs to land, then we can actually make sure that it only ever lands on, a cloud platform that actually has that assigned to it. Now, what does that 5 mean? Who knows? You're actually using encryption at rest, encryption in flight, a number of different things, right? So, effectively, you can just take these and turn those abstract concepts into something that you can consume in here via the blueprint. Or in fact, and Cody will probably show this a bit later, we've got the ability to overlay some of those things into the projects. So you might have your project set up in such a way that that you're working on a project that's using that's using customer information, and so you need to make sure that that's only ever placed in somewhere that's actually certified to host that data.
Yeah, so one quick thing, well, two quick things. Cody, one, you spelled packages wrong there in Cloud Machine 2. And second quick thing, the concept of tags here really is something that lets us bring business logic into the actual provisioning that happens with your blueprints, right? So Grant reviewed a couple of really great use cases, but you can really let your imagination be the upper limit as far as what you use these tags for. So they can be things like fast or cheap, or you indicate security or data sovereignty requirements, so that you can, again, configure these clouds once, the infrastructure administrator, your CAS owner can set them all up. And then these blueprint authors, or the blueprint consumers, if you will, can specify all of the tags and the business drivers that actually determine how their blueprint behaves. And they can be very simplistic concepts that translate to very complex tasks under the hood. So it's awesome.
I have so many questions, but
couple of quick things, and then we can answer. We can pause for a couple of answer questions. A couple things I did while John and Grant were talking. I added on a second machine. I added something called a cloud config. Cloud config is VMware's implementation of Cloud Init. Cloud Init being an industry standard cloud image customization tool. It's heavily used in AWS. It's used in Azure. Some images in GCP use it. You can install it on on-premises builds for vSphere. It's a very lightweight, easy to get started with customization tool. So in that customization tool, I have it pushing a package down for a web server just to back that HTTP load balancer up, and then a Postgres database just for so I can imitate a 2-tier app. I like how this blueprint looks for now. I'm going to version it to 1 real quick, and then I'm going to shut up for a minute and answer some questions. So I'm going to version this as 2-tier web app with Postgres.
Before you deploy that, Cody, how hard is it to turn that one machine that you've got there, having a single machine behind a load balancer seems kind of redundant. How hard is it to turn that into like a multiple machine cluster?
It's obviously very, very easy. So if I come here into this properties field underneath the first machine and I drop this down, I can go count and I can put in a number here, right? So that'll be 3. But I can also make this interesting. I come up to inputs and I can go machine count, type number.
The number or integer?
I thought it was number. John?
I'm pretty sure it's integer.
All right. Whatever. There we go. So now I've parameterized that, right? So I can actually have that be an input. When I hit deploy, it'll actually prompt for me. So I think we're going to deploy this, and while it's deploying, we can answer a couple questions if you'd like.
Sure. So the first question is from Graham Mitchell, and you actually answered it by typing just then. It says, he asked, if you update the code, will it also update the graphical portion? The answer to that is yes.
Absolutely.
Yeah, when you
vice versa.
Yeah. And so the second question is, can you ingest a CloudFormation template into this? Can you take a CloudFormation template and put it in here? Does it have an import method?
So within the blueprints interface, we do not have the ability to ingest a CFT there. But from a service broker perspective, we can take your CFTs and we can actually publish them out in Service Broker, so you could request them through there. I don't know if is there any CFTs in the lab? There is CFTs in the lab.
Yeah, we can do that. Yep.
Yeah, so we can easily show that. But any CFT that was built for AWS, we can actually publish out via Service Broker.
Okay, cool. The next question is a question about feature parity. How difficult is it for you guys to stay on top of new announcements from all the different, so we just had reInvent, so 100 new services. How fast before they make it into CAS?
Oh, John.
Oh my, that's a great question for me.
Jay.
Jay. We don't automatically bring in every new service that gets released, again, because this is an enterprise service or a commercially available service anyway. So we need to make sure that we properly test and make sure that any services that we do make available function within the framework that we've provided here. It does not take us long at all, and by that I mean it could be a matter of days to instantiate a new service. So if you find yourself as a Cloud Assembly customer looking for the ability to ingest some fancy new awesome service that AWS brought online at reInvent, we have a handy in-product chat. It's down there in the lower right-hand corner. You can communicate with folks like me, John from Tech Support, although I'm not online right now. And you can make feature requests there, and we'll definitely evaluate those services for inclusion because it is so easy for us. We want to be responsive and be very on top of that.
Very cool. One more question. The resource tagging within CAS, can you pass those resource tags into the subclouds? Like AWS has their own resource tagging capabilities, and for CloudWatch and stuff, you can base that upon resource tags. Can you pass down tags through CAS, or is it a completely different paradigm?
Yeah, we can write tags back to provisioned workloads as well.
Yeah, so probably worth calling out there. So what we're dealing with at the moment are what we would call the constraint-based tags. So those are free-form mechanisms that we use to inform the placement of where these workloads are going to land. Once Cody finishes in here, we can actually go back in and take a look, and we've definitely got the ability to add tags in as a separate stanza within the code there, and they get passed through to each of those cloud endpoints.
Yeah, and one of the three of us got wrecked on that yesterday for complaining that it wasn't there. So that's
which one was that, Cody?
Which one was that? I don't remember. Who was it that got wrecked?
That was the funny slide maker. That was me.
I don't think it was me.
Certainly wasn't Jay, that's for sure.
We do love to say that Cody really puts the marketing into tech marketing.
Wow.
Oh, these guys. If this wasn't vBrownBag, I'd say something.
Burn.
Anyways, so what I wanted to show here real quick is just to take a quick step through where I was at. I went into the deployment, which is finished, by the way. And if you look at the timing of this started at 14 and it finished very quickly thereafter. So it was a very, very quick provisioning for a very small amount of, a decent amount of infrastructure. If I pop into this allocation on the machine, you can actually see how that tag affected the placement of this workload. So we had two different clouds that were available, AWS and Azure. And because I tagged that, you can see that it landed over here. Green tends to mean good things, red tends to mean bad things. Azure obviously wasn't tagged as AWS as much as they wish it was. So the workload went to AWS. So that's a very simplistic view of how the tagging works. We use this scenario or this screen here very often to troubleshoot where workloads are landing and how they're landing. Next step, I'm going to dive in and show a couple of things about tagging, and then I'm going to hand it over to Grant so that we can roll forward on his part. He's going to talk about a couple of other things. If I pop into cloud zones, we've talked about this a few times now. We have our two cloud zones. These hold, in the case of AWS, it holds availability zones. Now you notice the tags are blank here, but on the summary view, they're tagged here. That means that Grant chose to tag these at the cloud zone level. So by doing that, it's telling the provisioning engine, I don't care which of these you land on, anything within this container, this can land on. We could come in here and we could tag each one of these zones with some explicit tags. For example, if I wanted to enforce that all workloads went to 1A, I could have tagged that here, and the provisioning engine would have sent it there instead. Backing up to project. Go ahead, John.
I was going to say something that's really cool on the compute tab there, Cody, if you head back over there, is that filter tags at the top there. So what's cool about that is it's important to note that's not just a UI filter. That is not just changing what you see here. What that's doing is actually making this cloud zone dynamic. So those filter tags, if you had applied tags to these individual availability zones that meant something, you could then use the filter tags to make the cloud zone dynamic. So anytime new availability zones or vSphere clusters or what have you comes online, they automatically become members of a cloud zone for which the filter is relevant. So it really adds a level of dynamism to these cloud zones.
Dynamism, word of the day, toilet paper.
Right. Wait.
Right. So with that in mind, you've seen now kind of what tagging is. If I pop over into project and I go in here and I look at provisioning, there are these concepts of project level constraints here. We can use these as another form of governance to help direct what type of workloads can be consumed. For example, if I had a zone that was tagged as public internet, just as an example, and I wanted to be able to have public IPs provisioned there, but within this project, I wanted to restrict that ability, I could easily put that in as a project level constraint, as a provisioning level constraint, and restrict the user's ability to consume those tags. So they could apply them in the blueprint. Note that blueprints are project level entities. So if you have 5 projects, your blueprint is not shared amongst all of those projects. It's specific to the project you created it in. So we can use this interface here to restrict the type of things that can be consumed within the blueprint interface. It just gives you another level of governance at a project level as the administrator who's trying to build and secure this cloudy thing. So again, stepping through a couple of these real quick before I turn it over to Grant. We set small. We've obviously built these small entities here around what a small is defined as. In AWS, it's T2 small for us, and then in here, it's standard B1MS for Azure. And then image mapping. It's really defining out AMIs, Azure Images, templates. We have the ability to provision the content library now, so we can consume remote or local content libraries. So I did a video earlier on integrating with VMware Cloud on AWS, and I showed that we can actually discover and provision templates that live inside of there. I have William Lamb's nested vSphere hooked up to my lab, so when I go in and try to provision, I can call down nested ESX, so I can provision nested ESX from inside of CAS, which is really cool. jumping into cloud accounts real quick, you can see the different options we have available here. It's nice to see these guys are back now. But we have the ability to provision out to AWS, Azure, VMC, standard vCenter. Standard vCenter and AWS or VMC and AWS are interesting because they use something called the cloud proxy. Cloud proxies are how we communicate on-prem. So we have how we are able to do provisioning against your on-premises data center using cloud automation services. We're not going to dive too far into that one today. We have the ability to integrate with Orchestrator, Puppet. This lets us pull down things out of the marketplace, content out of the marketplace right now. More feature functionality coming around that. And that's like the most Mach 3 version of the infrastructure tab I've ever done. Grant, you ready to rock?
Yeah, do you just want to maybe cover off the mappings super quickly in terms of what they are and why they're important?
Yeah, so the big thing about mappings, if it wasn't kind of discovered through what I implied there, is that the mappings are how we create a relationship between those clouds, right? We're heavily focused on being able to do things across multiple clouds. John touched on that from how the cloud agnostic objects work. We've talked about it several times along the way. And you can't really do a cloud agnostic thing without understanding the definition behind what each cloud has. So we map these concepts like Ubuntu. We map out to a definition inside of each cloud, right? So Ubuntu in AWS means this AMI. Note that AWS has like 85,000 AMIs available. So you really want to be able to be specific. This is how we do that. We take a name, Ubuntu, and map it to individual objects within each one of those clouds. Same thing applies for flavor mappings. We take cloud-specific terms and map them back to terms that you're familiar with inside of your data center. A small t-shirt size can be mapped to whatever you want it to be in public clouds or in private cloud. All right, I think we're going to turn it over to you, Grant.
The same sort of thing applies, just to touch on it real briefly, the same sort of concept applies to those network and storage profiles, right? So the theory there is we can take the very cloud-specific concepts that underpin networking and storage in the clouds, VNets and VPCs and NSX config, and map them to very cloud-agnostic constructs. So that's what enables you to do things like drop a load balancer on a blueprint and have it work in any cloud. So the network and storage profiles are important there as well. But go for it, Grant.
Brilliant. All right, so what we're going to spend a little bit of time on now. How much time do we have, actually? Another 15-ish?
Yeah, we're good.
Yeah, cool. All right. So what we're going to spend a little bit of time on now is just taking a look at what we're doing with regards to extensibility with all these services. So for those of you who played with vRealize Automation at all, or in fact, even if you haven't, you may have come across vRealize Orchestrator and seen some of what we do with that as a workflow-based engine. So we're continuing to invest and work on the integration of vRealize Orchestrator with this platform. And in fact, if you take a look here within the Extensibility tab that I'm in a different org to Cody since I wanted to have some pre-populated content in here. We're actually able to expose the vRealize Orchestrator workflows in here and trigger those to perform any type of integration or extensibility tasks that we're looking for. So I haven't actually filtered these off. I just wanted to sort of show you that everything actually comes through. So, some of the typical examples that we see an awful lot of are things like IPM integration, doing work with, say, on-prem F5 load balancers, reaching out to some kind of secret server to generate passwords or generate certificates, potentially integration with config management, etc. So they're the types of things that we typically see people doing with extensibility, but to coin the same phrase as John used earlier, you're really just limited to your own imagination in terms of what you want to do with that.
So Grant, I'm super overwriting JavaScript in VRO. What if I don't want to do that?
If you don't want to do that, well, then we've got a really cool alternative option for you. Thank you, Cody.
Grant, why are all your projects named like that? What do those words mean?
Crikey, it's a Python.
So you know what I love? I love working for an American company and our meetings being set at really useful time zones for me, and all those Z's that come through in our official presentations. And the fact that you take use out of all of the words that are meant to have them in there. So I just wanted to put my own sort of polite Australian slant onto our demo instance here. So barramundi is something that you eat. A Tassie devil is something that will eat you. Yeah, there's a few other different projects in there, but they're all pretty much Australian animals. Or in fact, that's not quite true. Since this is actually a shared organization for our Asia Pacific and Japan group, there's a few other sort of native species in there from the different areas. At any rate, back on topic. So Python, another animal, although not named for it in this case. If you wanted to start working, for example, in Python, this is where we start looking at what we've done with our the introduction of an alternative extensibility-based platform. Now, when we start looking at public cloud services, you might say, what's the point of having VRO sitting on premises, having to open up the firewall rules, etc., for it to then get out and manipulate and start working with public cloud objects? So what we've introduced and what we're taking advantage of is the ability to use functions as a service off the public cloud providers. So what I'll do now is just take you into, I guess, a little example that we could be doing with action-based extensibility. If you are a lover of JavaScript, then we still have Node.js support. You can actually continue operating that way. But if, like me, you prefer working with Python, then you've got some interesting alternatives with regards to what you can actually do. So here's some, I'm just going to take you through a few things here, and you'll see VMUG UK. I was there last week presenting, and if it's not obvious, I presented on some of this. And basically, you can see here that we've got the ability, and if you've worked with, again, Lambda at all, this probably looks very familiar to you in terms of how we're operating, right? So we can import modules that we want to make use of, and then we can start taking advantage of those in combination with the payload that we actually get from the request that we pass through. Now, this particular one is a very simple example. We're just calling out to AWS Systems Manager to retrieve a particular parameter. And in this case, you can see here that I've defined the parameter to be the value of the VMUG UK Slack webhook. So again, another example around integration, and something that Cody's been playing a bit with over the last little while is the idea of chat ops and what we can do with regards to that. So in this case, we're just looking at notifications, but you can clearly start doing some more advanced and interesting things with that. So in roughly 11 lines of code, I'm able to go out. In this case, I'm retrieving a Slack webhook. I could also be calling out to a secure store to retrieve a password, as I mentioned earlier. And then we're able to pass that back. Let's take a look at some of the sample actions that we actually provide with the platform to really get you up and started on this. So some simple examples that you can make use of. So, tagging was a question. We can do native tags, or we can actually use extensibility to do that. We can assign an IP to a VM. A different example in here is the ability to actually poll an endpoint and look for a particular status or a particular value to come back, so that you can know whether to progress after, you pause your provisioning to wait for some kind of other task to actually occur. What I'm going to do in this case is, which one will I do? I might take a look at the tags, because that's fairly easy to understand, fairly easy for me to explain. All right, so if we take a look on the right-hand side here, we can see that we've got the inputs set up to be, here's what our tags are. Now, these clearly are hard-coded as part of the function, but again, you can actually take the payload that comes through from your workloads and effectively you're merging that with the inputs that we describe here. So your payload from the machine is an array. We just simply append any values that you put here to that array so that we can make use of it. If we start actually walking through that Python function, we can see here new tags. We're actually assigning the inputs new tags to be this. We're creating an empty array, not an empty array, an empty object for outputs. And then we're saying, okay, our output tags now equals our input tags. And then for each of the key values in here, and these are being passed through as an object, we're going to iterate through and say output tags, key name equals value, and then we're just appending that back. So it's a really simple way to begin interacting with our machine payload, add additional values to it, and then write it back to the resources to provide customized values or additional metadata that we want to as part of that. Hey mate, my son wants me to play Beyblades with him, and he'll be out in a moment, mate. We can play together. So that's one very simple example of actually manipulating it that you can actually do. Let's take a look at how easy it is in this case to actually go about getting our payload. So if I scroll down here, you can do log payload. We're able to take a look. You can see here we can show any subscriptions that are actually set up. So in the same way that we do extensibility today with vRealize Automation, we basically have a message queue sitting there listening, and then based on conditions, we're going to trigger these actions. Now, I don't know, again, how many people actually did this in the past, but do you remember how difficult it was actually to get payload out of VRA and understand what it was that you're actually seeing? This is how simple it becomes to actually get that payload and take a look at it. So we're just doing a JSON dumps on the inputs. I'm prettifying it here, so doing an indent of 2 just to make that look a little bit simpler. And we'll go in and we'll do a look at one of the runs to see what actually comes back as a result of that. So here's the output, which again probably doesn't mean a lot within context at the moment, but just showing you this is how simple it is to start actually getting the data and then interacting with this and using that to pass through different stages. So really, really cool, very, very simple means of actually starting to provide advanced extensibility capabilities. All right, moving on to something that's a little bit more of a complex idea. And where is our flow? There it is. So I showed you simple actions, and now what I just want to quickly touch on is how we go about actually chaining those together. So I've got, again, a sample here that I created earlier, and you can see on the right-hand side, so the same idea as before, we're trying to make this all very portable, very easy to version. So we're really looking here at a bunch of actions as code, simple YAML format to describe what this actually looks like, and then a visual representation on the right-hand side of screen there regarding what that's doing. Again, if I click on the visual element, we see that it highlights the code. So it just again starts to make it easy to navigate and understand what's going on with regards to that. So the first thing I've done here is create a fork. And you can see here I've got basically an array here talking about what the next actions are going to be. And since they're splitting out, we're assuming that they're going to be running asynchronously. So that does that. In this case, we're going out to get a parameter from Systems Manager. And I was just performing a simple math function. So basically retrieving a starting number as well. Once we've got those two pieces of information, we perform a join, which is what's occurring down here. Now, the reason a join is important is because if we don't perform a join, then whichever action finishes last, its output is actually going to overwrite everything and just be, a single input to the next action, which means that things aren't going to behave as you want them to. So what the join does is it takes the outputs of all the different actions that have run asynchronously, it merges them together, and then it passes them through to the subsequent or the following action as the inputs, which we come down to here. So we send a Slack notification, we perform some simple maths, basically, and then again we send an additional Slack notification to say, hey, okay, here's the new number, or here's the output of the maths equation that we actually ran. Now, this looks a little bit confusing potentially, and when you look at something like the action ID, you go, oh my God, do I really need to actually remember what this value is going to be? That seems to be. Now, as you can see, and I just deleted it there, we've got the same type ahead, the same lookup as we actually have within the other areas of Cloud Assembly to make this quite easy for you. So I can go and I can select my number equals number plus 1, and to make your life easy, we put a comment string at the end of it to let you know what the action name actually is that's associated with that unique ID. So again, really trying to make this whole process a lot easier, a lot simpler for you. And you can perform complex tasks, create multiple discrete actions, and then combine them together in whichever way you like in order to get to the outcome you're actually looking for.
I think it's pretty awesome to be able to chain together, like the way that this, what's powerful about this is the ability to chain together multiple function as a service concepts into like an overall like workflow, really. It's something that when you look at, like FAS is a big thing right now, and it's obviously getting a lot of popularity in the whole serverless world and so on and so forth. But nobody's really looking at how to chain those together, right? And it's something very unique, and it's a unique value prop that we're offering, the ability to chain together these FAS actions and having them result in something.
It's pretty cool.
And it lets you use existing, a lot of people know Python, a lot of people know these languages. Not a lot of people automatically know JavaScript or VRO. So it really gives a whole new meaning to, extensibility, and opens it up to a lot of new people, a new generation of, coders.
Nice.
Absolutely. So I'm just getting plugged in. You can probably see that I'm going to
7%. Grand Orchard playing with fire and crocodiles.
There he goes.
Oh, he plugged it in. Good save.
Brinkmanship.
That was close.
So one quick and why Python and not Power CLI?
Be patient.
Yeah, that's a good question. Be patient.
Okay.
Well, so there's one answer, which is be patient. There's a second answer, which is looking at the different languages that are actually supported as far as this stuff goes. So we do have .NET Core as a support in Lambda, clearly. So you may have a possibility of seeing PowerShell come through here. But as far as CLI interaction with the product goes, watch this space.
Okay. Graham immediately followed that up with how patient, but that's getting too close to NDA, Graham. So cut it out.
If it was
we don't want to go too deep into that, but not terribly patient.
Right.
If it was a long-term thing, we would say it's on the radar.
Oh, okay.
We have our own little code language, I guess.
Nice.
Here comes Santa Claus. Here comes Santa Claus. Oh, sorry.
I love that song. Cool. So let me double check everything in terms of Q&A. No, I think we're good. I think we are good for questions, gentlemen. Any last comments? Anything else that we want to bring out at the end?
There's something, Grant. If you don't have anything else, I got one more thing to talk about.
Sure.
Swage.
Yeah, there's this little thing called Swagger, which is like a documentation method for APIs. And I just thought it might be useful to point out that all the API documentation is publicly available, so you don't actually need to be subscribing to the product to be able to come in and actually take a look. Everything is actually in here, which is cool. So I've just taken you to the IaaS API, which again allows you to take advantage of stuff like creating machines via API with a single API that is cloud agnostic, and have our placement algorithm sort of handle that for you. So there's some really cool stuff in there. All of the API docs are available. I think Cody mentioned this. They did actually blog this. So you can go and look at not just the IaaS API, but also stuff like how you can programmatically create things like blueprints, maybe from, hey, a Git repo, since we're doing infrastructure as code, and actually start looking at how you can interact and accelerate some other initiatives and different ways to consume this outside of the UI.
Very cool.
Grant, since you're in here, will you just open one of these posts, like the one you're looking at right there?
Sure. Let's pick a decent one though, shall we?
Sure.
Posts.
There we are. So you can see the whole payload is here. We have examples published, as well as the overall model that contains great detailed information about each of these payload objects. So these APIs, super easy to consume.
Very cool.
Very easy to consume. All right, Cody, jump in, mate. You were going to say something.
Yeah, just kick me back the ball real quick.
I got
it.
I got it.
There we go.
All right, so one more thing to show off. So we talked a lot about deploying workloads. We showed extensibility, but something else that's really big in the platform is the concept of iterative development. So we have this two-tier build right now. But what if we wanted to add on an additional machine to this, right? So say I wanted to come out and I wanted to drag another machine on. I want to wire it up in the same way, all right? So I'm going to add it on here. Maybe I'm going to change this guy to also be a fixed count. So I'm going to go count of 4 just because we're running low on time and I want to do it fast. It'd be silly to do 4 Postgres databases behind a set of web servers, but play along for grins. We'll go image, Ubuntu again. We'll do flavor. We'll change that to small. We'll add back in our constraint, as we would expect. We'll tag it with platform. Oops, not vSphere, sorry. AWS. Now I'll version this up again, and I'll go to version 3. Some things. Okay, we'll go into version history. 2 things I want to show before we end this. 1, we can look at this versioning and we can go in and do a diff against old versions of the blueprint, right? Cool. So we can see how from version 1 where we started, we've added in inputs, we've had counts change, we've added in another machine. We can easily see the way that this blueprint's changed. We can also see a visual representation of that. And here's where things get really interesting. We can deploy this, and we could deploy this as a net new workload, but we can also go in and we can update our existing deployment with this. So that's a 2-tier app now. We're not obviously going to change it from that. We can leave the machine count alone. But you'll notice this plan indicates the things that are going to be added, things that are going to be updated, and things that are going to be deleted. Because I added on a count object to that machine 2, it has to go away because it has to be recreated with the new number. But many of those objects aren't going to change. Like the load balancer, it's going to stay the same. Nothing's going to change to the existing deployed machine. It's simply going to update. Now, what if I wanted to cancel that, but I wanted to come in and I wanted to add on an S3 bucket, right? So I can come in here, I can find an S3 bucket. I wanted to add it onto the end. If I could drag things around a little bit cleaner, that'd be great. So notice we have the ability to interact with cloud native objects now.
So when you're adding that S3 bucket, and then you tied it, or you clicked on it and then tried to tie it to the cloud machine, was that creating an internal endpoint for the cloud machine to consume it?
No, that was creating a dependency between the two to say that this is not going to deploy until this one's ready.
Okay, all right.
I think I have the name wrong. Grant, do I have that wrong? Is it trading AWS or is it AWS trading?
Trading. I think it's trading AWS.
Oh, that's weird because I have it set right. Interesting.
So in CFT speak, would that be a depends on the resource?
It would depend. It would require it to be deployed before the other one would. So before this would deploy. Yep. The machine would need to finish first. Gotcha. Okay, so it's called in the resource it would be called a depends on. That's a YAML tag that you type. Cool. That's right up there. There you go. So now I can deploy this. I can update that build, and what it's going to do is it's going to instantiate that new machine. It's going to instantiate that S3 bucket. It's going to update this, but it doesn't destroy those existing machines that were already built. It's iterating on that existing deployment, which is a very powerful thing when you're trying to craft and grow a service from nothing into being useful, right? So I wanted to really show the iterative development. Now that we've seen the extensibility, we understand how we can interact with other platforms. We can also iterate on existing platforms as well. That is very cool. Is that running an update on the for AWS specifically? Is that running an update on the pre-existing CFT, or is it blowing away the old CFT and creating a new one? I'm assuming it's running an update. From a CFT update perspective, I don't know the answer to that. Grant, John.
Yeah, so we're not actually working with a CFT in this case. Remember, so you've built a Cloud Assembly blueprint here. So okay. What it's doing is you're actually just applying the blueprint is a declarative state model. So you're taking the declared state within that blueprint where you say, here's what I expect to happen. Mm-hmm. And it's applying it to the running state of the infrastructure. So that's the actual state. And what it's doing is bringing the two into sync together. So it says that the actual state is X, the declared state is Y, and it makes the actual state equal Y. So that blueprint is static object within Cloud Assembly, but it's taking that and making your dreams come true in the cloud by executing, on that declared state.
So okay, so I misunderstood. It's not a CFT under the covers. This is direct to the you're bypassing the CFT process.
Yes, we're not using CFT at all. You're authoring a Cloud Assembly blueprint here.
Thank you.
No problem.
Correct. We can do CFTs independently, right? So if we wanted to interact directly with the CFT, we could do that individual CFT interaction inside a service broker.
Yeah, but this gets the middleman out of the way.
Exactly. This is direct provisioning to AWS.
That's awesome.
And of course, CFTs are not cloud agnostic. So if you're crafting a CFT, you're building Amazon-specific services.
Right.
Not that there's anything wrong with that, but we imagine a world where you may not care which cloud you're in.
No. So I misunderstood. I thought that what this was doing was it was writing either a CFT for AWS or writing an Azure blueprint for Azure, and then acting upon that. But it's not. It's getting rid of both of those constructs and applying it directly.
That's right.
And I think that's all we got for you guys tonight. Obviously, we can come back in the future and we can do more of these and talk a little bit. We only touched one service, right? So we got like 33%.
And only just barely, yeah. So there's so much robustness and richness here within Cloud Assembly, and we didn't even talk about CI/CD or service broker or policies and governance and all the cool stuff we can do. So
I think I'm smelling a series here.
Right. Maybe after the new year.
Yeah, yeah, of course. Yeah. No. Speaking of which, Merry Christmas, guys. This is the last one before Christmas. So, yay!
Yay!
Cool. All right. Well, gentlemen, thank you very much. This was really, really good stuff. Cody, I now know why you were so excited when we were chatting about this in Barcelona. This is really, really fun and very powerful stuff.
Awesome. Thanks for agreeing to come and host it for us. And this is this was the first thing because we really wanted to show people the hands-on lab, and like it's important to understand none of this was secret sauce, right? Like you guys, people who are watching this right now can go and do all of this in the hands-on lab today. So
fantastic. Cool. Well, gentlemen, once again, thank you very much. And we will be seeing you guys again on the next of the new series on VMware CAS.
Thanks, guys.
Awesome. Looking forward to it.
All right. Bye-bye.